Gear oils are a fundamental component. They're a little bit like bearings or couplings in that they're present in most mechanical applications. The challenge with that is that there are so many different types of gear sets and they're used in so many different applications that it's a challenge to formulate for all of these different types. So, how can we parse out the different needs of different gear sets and how do we get to a gear oil formulation? Let's explore it. All right, so let's talk about gear oil formulation. The challenge with gears is that there are so many different types. Just think spur, bevel, helical, herringbone, spiral bevel, hypoid. And really, the other thing about them is that they are applied so differently. So there's so many different use cases. And if we look at the Strybeck curve, for example, this is an old friend of ours, where you look at the coefficient of friction versus this non-dimensional number, which is supposed to express speed, load, and viscosity, what we see is three very clear lubrication regimes, right? We have the boundary, we have the mixed, and we have the hydrodynamic lubrication regimes. Now, in each of these different regimes, we have a different part of the lubricant which tends to dominate the frictional properties. So, in hydrodynamic, it's predominantly controlled by the viscosity of the bulk oil, and then we have anti-wear and EP additives that can help us when there is metal-to-metal contact. If we were to group these into very broad categories, we would say that at the left-hand side of the curve, we rely on additives, and on the right-hand side of the curve, we rely on base oils. But the different, let's say, loads and speeds that are applied to gear sets and the different types of gear sets, that's not it. Right? We also have the different applications. So we have, for example, standard industrial enclosed gear drives. We have automotive gear sets, which have completely different requirements. We have open gear sets, for example, on ball mills, and we have the specialized wind turbine gear sets. So what are some of the commonalities between these? Well, if you think about some of the environmental factors, right? Sometimes we experience high temperatures. Now, the degree of high temperature that we experience is different, for example, in a gearbox for a kiln, as an example, versus a wind turbine gearbox. But the friction and the heat that is generated by some high loads can often result in high temperatures. We often have water contamination. So water contamination is present either in the environment, think of offshore wind turbines having to deal with sea spray. It could be paper mills, for example, which are often have a lot of humidity and moisture in the air. So we often see a lot of water contamination. We often see particulate contamination. Think about gear sets at mine sites, for example. This is a particular problem for open gear sets, which don't have that much protection from the elements. And we also have foaming. And this is part of the nature of how gears are lubricated, in that it's either splash lubrication or maybe it's mist. Maybe we've got nozzles that are firing lubricants at the load area. So because of all these things, we're going to get a lot of entrained air, and there's often a lot of sloshing and movement of the lubricant around the gearbox. That can often cause foam. So how do we tackle each of these environmental factors? Well, for high temperatures, what we're concerned about is going to be oxidation. So high temperatures is going to accelerate the oxidation of the base oil. And really, aside from using a very high quality base oil, the only other, if you like, weapon that we have in our arsenal is to use antioxidants. So you'll often see phenolic and aminic antioxidants in gearboxes, depending on the temperature. Phenolics usually work at lower temperatures and aminics work at higher temperatures. Then, of course, if we have any anti-wear, such as DDP, for example, it can often act as a secondary antioxidant. For water contamination, we're predominantly concerned with two things. And the first of those is corrosion. So we know that water can accelerate the corrosion process. And in order to cope with that, we need corrosion inhibitors. Similarly, if we have a lot of water contamination, we might start to get concerned with the formation of emulsions. We know that emulsions wreak havoc with lubricant films, and they also increase the bulk oil viscosity. If you'll remember, if we mix oil and water, they're both relatively low viscosity, so vegetable oil and water. But if we stabilize them to form an emulsion, we get mayonnaise, which is very thick. So demulsifiers can help ensure that the water and the oil stay separate. Then we've got particulate contamination. Well, to deal with those, then we have to use detergents or dispersant systems. And finally, with foam, really all we have, aside from increasing the residence time in our reservoir, is to use antifoamants. And these are usually polymethacrylates, or they might be silicon antifoamants. Now, there are a couple of other lubricant additives that we might have in a gear oil based on very specific applications. So we might need friction modifiers in automotive gearbox, for example, or if we have an open gear set and we really need the fluid to adhere to the surface of the gear teeth, we might need to use a tackifier. But broadly speaking, antioxidants, corrosion inhibitors, demulsifiers, detergents, dispersants, and antifoamants are going to be present in most gear oils. Now, let's think about the proportions of those two. So if I have a fully formulated oil, I expect it to be made up of basically like an additive package as well as a base oil package. Now, the relative proportions of those are going to change depending on the application and the type of gear oil we're after. But in broad terms, you could probably say for a gear oil that the additive quantity is anywhere between, let's say, 10% and 1%, right? Depending on the quality of the base oil as well as the application. So among those additives, then we would expect that the vast majority of the additive pack is made up of anti-wear and EP, and a smaller portion is retained by all those other different additives that we require. Among the base oils, this is where you get quite a lot of variation. So for example, if I wanted a straight mineral base oil, maybe I would mix partially a solvent neutral group 1 as well as a bright stock, right? And using those, I could get myself to a pretty decent gear oil. Now remember, with something like gear oil, in a lot of industrial enclosed gear drives, they really only operate at a single temperature, or at least the temperature range is not as large as, say, for example, an engine oil. For that reason, we don't really need a very high viscosity index, right? So where we would usually desire in an engine oil application for a group 2 or group 3 for their high VI, we don't really need that in a lot of industrial gear drives. What we might want, though, when we go to a synthetic gear oil is a low traction coefficient. And that might be one of the things that pushes us towards a full synthetic PAO and ester type base stock. Now, PAO and ester is also going to help us with oxidative stability as well. So in high temperature applications, maybe that is an argument to move to a full synthetic. Now, there is variations on synthetic gear oils as well. So for example, if we are looking at really high temperature applications, I've seen examples where, for example, the ester gets swapped out for an alkylated naphthalene. Or in some instances where the alkylated naphthalene is actually the primary base stock and the PAO becomes the co-base. I've seen that too. Now, what if we have, for example, a worm gear drive? Well, there's a lot of sliding that goes on in a worm gear drive, and often one of the gear sets is going to be made of yellow metals. What does that mean? Well, now we have to be a little bit cautious about our EP additive pack, because EP additives can often be too chemically reactive for yellow metals. What that might drive us to is actually a base oil package that's predominantly polyalkylene glycol, because it has really good lubricity, and we can then reduce the amount of EP and anti-wear that we have in our additive pack. In some cases, we're reducing the EP down to 0. So these are the kind of levers that we can pull in the additive package to help a gear oil, which is this kind of generic term. How can we make it fit our specific application and our specific requirements?